Hi, this is the second video for Year 1, Chapter 14 of Exponentials and Logs. In the last video, at the end, I asked you to sketch these two graphs. So I've just got these so they can show you the answers. So this one is going through the y-axis at 5 and the asymptote is at y equals 1. This one is going in the opposite direction, going through 3 on the y-axis, and the asymptote is at y equals 0. Okay, so hopefully you did well on that. I just wanted to show you a slide showing exponential graphs in a context, so they're very widely used. You might have seen some graphs like this during the coronavirus pandemic, for example. There's been lots of graphs shown. These two show exponential growth, so something that starts off quite slow and then rapidly increases. And you might see these in science, in biology particularly. And then this is an example of exponential decay, so over time. So notice how both the horizontal axes, all the horizontal axes are time. So when we're talking about something exponentially growing or decaying, it's over time. Now, when we are working with these exponential graphs, particularly if they're in a context and we're using these to model particular real-world problems, in order to do calculations with these, we need to be able to do logarithms. So this lesson is all about what is a logarithm, how it relates to exponentials, and then we will go from there looking at how to use logarithms. Okay, so just to explain what a logarithm is, I'm just going to show you a graph, a linear graph. So here's a graph of y equals 2x plus 1. We know that's a straight line. We know what it looks like. It goes through the y-axis of 1. We know it's got a gradient of 2. We know lots of things about it. If we were given an x value, then we could substitute that x value in, and that would tell us the y value. If we were given a y value, then we could substitute the y value in, and because we know how to do inverse operations on this, we could solve for x. So we take 1 and divide by 2. Okay, so we can work out x values for given y values by using inverse operations. And we can do that for lots of different graphs. If we know a y value, then we can solve for x. So x will be the square root of 25, which is plus or minus 5, because we know that the inverse of x squared is root x. Now, if we now consider y equals 2 to the power x, so I'll just sketch that. We know it goes through 1. So that's going to look like that, converging to the x-axis, and then going through 1. Now, when we are told an x value, let's say x equals 3, then we can work out the y value by saying it's 2 cubed, which is 8. Okay. But what happens if we are told what the y value is? Can we work out the x value in the same way? Well, 25 equals 2 to the power x. What we need to be able to do to work out x is to be able to do the inverse operation. Okay? And that's exactly what a logarithm is. A logarithm is an inverse operation. Up to now, you wouldn't be able to do this because there is no whole, there's no integer that will give 25. 2 to the power 4 is 16. 2 to the power 5 is 32. So that's 16. 2 to the power 5 is 32. So we know x must be somewhere between 4 and 5. there is, if I just draw 25, there is some x value between 4 and 5 that gives a y value of 25. We just don't know what it is yet, but we can work it out by using logarithms. So a logarithm is an inverse operation of an exponential. So I'm going to show you now how we would rearrange this using logarithm form, and eventually I'll show you how to get that answer off your calculator. So we start off with this. This is exponential form, and this is logarithm form. As these are inverses of each other. The B stands for base, the P stands for power, and the A stands for answer. So for example, you might have 2 cubed equals 8. Base 2 to the power 3 gives an answer of 8. Now this can be written in log form. So in other words, we are rearranging it using the inverse. And we do that by using this. So log, which is short for logarithm, of base b, so that corresponds to that, of the answer equals the power. So in this case, we could write this as log to base 2 of 8 equals 3. This is exponential form, and this is rearranged into log form. So just like when you're rearranging the subject of a formula by doing inverse operations, that's what we've just done there. So to get from here to here, we are rearranging using inverse operations. Exponential and log are inverse operations of each other. Now it's very important going forward that you can go from exponential form to log form and vice versa, because you'll have to do it a lot. Okay, so that's what we're going to look at now, just how to do that. So here's some examples. We're going to convert from exponential form to log form first. So 2 is the base, so it's going to be log to base 2, and this is a little subscript 2, it's got to be smaller, of 8 equals 3. Okay, so make sure it looks like that. Don't do a big 2. It's got to be a little 2. Here 7 is the base, so log to base 7 of 1/49 equals -2. Here 10 is the base, so log to base 10 of 100,000 equals 5. And here 3 is the base, so log to base 3 of 81 equals 4. So that's going from exponential form to log form. Now we go the other way. So we've got log, base, answer equals power. So 2 is the base, 5 is the power, 32 is the answer. So 2 to the power 5 equals 32. 3 squared equals 9. 4 to the power 0.5 equals 2. 10 to the power -3 equals 0.001. So that's going the other way. So I would like you to pause the video, and by writing these in log form, you should be able to easily work out what x is. Pause the video now. Okay, so we'll just go through the answers. So x cubed equals 125, which means that x is the cube root of that, which is 5. 9 to the power x equals 3. 3 is the square root of 9, which means x must be a half. 10 to the power 6 is x, which means x is 1 million. 4 to the minus 3 equals x, which means x is 1/64. And this one, well, we've got 3 lots of the log. So the first thing to do is divide by 3 to give 8. And then we go from there. So 2 to the 8 equals x, which means x will be 256. 2 to the power 8, which is 256. Okay, so just be careful here. We can only go to exponential form when just the log is a subject. Okay, now on your calculator, you have this button. On some older calculators, there's both. Oh, what I should say, this one here, log to base 10 of x, because we use base 10 a lot, all our number system is in base 10, 10, 100, 1,000, etc. Because we use log to base 10 a lot, log to base 10 in textbooks, you will just see without the 10 there. So if it just says log x, then that means it's log to base 10. And you just assume that. So that's really important. If there isn't a little base there, and it just says log, then you know it's base 10. So calculators, on the new calculators, we've got that button. On older calculators, we have both. This will be base 10. On the Casio Class Whiz, we just have this button here. So this is for the base, and this is for the answer. So what I would like you to do is find your button and do both of those tasks. So pause the video and please work through both of those tasks, and I'll show the answers in a second. Okay, here are the answers. So if you can check those. Okay, we'll pause there. I want you to do exercise 14D, page 320. Don't use a calculator unless it's stated. The reason being is because I need you to practice moving from exponential form to log form without a calculator. That's the end of this video.